Welcome everyone to the next episode of Listening to the Wind, IWSA's regular interview series. And I'm delighted to be sitting with a couple of representatives from Vaisala, a global leader in weather, environmental and industrial measurement instrumentation and services. I'm sitting here with Timo Kerola and Mikko Nikkanen. Hi, Mikko. Hi, Timo.
Hi.
Thank you for joining me. I'm going to give a quick introduction to you both. So Timo Kerola works as a product manager in Vaisala with responsibility over wind and weather sensing products. Timo joined Vaisala in 2013 and since that has had several different positions, both in research and product management. Timo holds an MSc degree in micro and nanosciences from Aalto University, which sounds very interesting. Mikko Nikkanen is the head of maritime weather and environment at Vaisala. Mikko leads strategy and development for Vaisala's maritime and port segment. He's established Vaisala's maritime focus in modern weather awareness solutions, bringing 20 years of global sales and business development experience to build innovative solutions with various partner ecosystems. So Mikko, Timo, I think we're in very good hands to hear all about your company, what you're doing in the wind sector. So without further ado, I will hand the reins over to you for your presentation and I'll see you on the other side.
Okay. Thanks, Kevin, for the introductions. Let me share and let me know if you're seeing this well.
Yep, looks great. Needs to go to slideshow.
Yeah. So let me go through quickly what is Vaisala and what is our role in the wind-assisted vessels. So Vaisala is a global leader in weather, environmental and industrial measurements, and we have a track record of 85 years in this business. Our revenue is around 437 million euros as of last year. We cover over 150 countries in the world and having around 2,000 employees worldwide. And we are truly in the sustainability of our businesses. We are also using renewable electricity for our company ourselves. So truly in this business. We believe in sustainability and observe the climate change and kind of make sure for our customers that they are climate resilient when there is extreme weather impacts, and we provide the observations, forecasting and early warning systems for the markets, and increase overall the understanding of the environmental impact of their businesses and operations. We are divided in two business areas. The other one is weather and environment, where we are working together with Timo, and then we have the industrial measurement area, which is mainly for the indoor measurements to optimize processes and improve efficiencies on that inner side. For the weather and environment, we have a wide selection of sensors in the portfolio, and these are mainly provided to the application areas as meteorological companies, aviation, transportation companies, and maritime, of course, included there. And there today we are talking about mainly about our wind sensors, which is on the left side, the pressure, wind, humidity, and multi-weather sensors, and then the remote wind measurements, which are based on the LiDAR technology, which are in the middle of the picture. And when we are talking about the Vaisala in maritime, we are working on the three main application areas, which is including the ports and coastal monitoring, typically helping there the ports to have more cost-efficient operations and more safe operations there. And then the offshore, where we are working for the renewable energy, where they are building the new wind park installations, for example, this type of special vessels like the VTIV, which is the wind turbine installation vessels, and there we also provide environmental measurements and remote wind data and also the helitech monitoring systems in this market. And then on the right side, we have this ship instrumentation area where also part of the wind assisted vessels are belonging in this category. And when we think of the wind and weather sensoring for the wind assisted vessels, this picture probably shows a little bit about the situation where we are living on these vessels. You have different wind conditions in different parts of the vessel. So at the front of the deck, you might have maybe heavier winds coming up, and at the back of the ship, you might have totally different wind conditions. And then, of course, you have also impacts from the superstructures of the vessel, which might be impacting on the wind measurement results here. And then, of course, the incoming wind conditions which the vessel is confronting might be changing. There might be some gusty situations coming, especially on the coastal areas or in the front of the thunderstorm area. So anyhow, there might be different conditions even on the vessel. And then we go for the deeper into the wind sensing technologies by Timo.
Yeah, thanks, Mikko. So next slide, please. This is just the overview of some of our wind sensing technologies and a few products. It's not an in-depth technological presentation, so if you want like more details, go to the Vaisala.com website. But just to get started, we have over a 40-year track record in different wind measurement products. Started in 1973 with this WA11 and mechanical sensors, now having ultrasonic sensors, WMT700, and then the WXT530 platform or product family, which has multiple different variants. WMT700 is the flagship ultrasonic wind sensor. It was launched in 2010, and it's used like throughout the globe. It's especially successful in this aviation or other, let's say, security critical markets where you absolutely have to have the best measurement in all weather conditions. And it's used very commonly in airports and airfields, etc. But in addition to that, of course, we are very familiar with the wind energy sector and also the maritime sector. And both these WMT700 and WXT530, they have been like certified and tested, and they have different kind of like accreditations to, for example, this DNV certificate. So it's not a new industry, this maritime industry for us, like at all. Next slide, please. So if we're looking at the ultrasonic measurement principle, it's actually really interesting, this wind cap technology that we have. So essentially we're using a 3 transducer model, and some other players on the market, they have 4, but we have this great idea that 3 is more than 4. And the way that we do it is that we essentially have very many different measurement paths, and we send essentially a burst of sound from these transducers, and then we measure it at 2 different transducers, and by this way we can have essentially 6 different paths where we can measure, and that makes up a very redundant wind measurement. And for example, one characteristic is that it's not dependent on the ambient temperature, the ambient pressure at all. So when you do the final calculation, it's really, let's say, good wind calculation that we can produce with this kind of sensor design. Next slide, please. So WMT700, like I said, this is the flagship wind sensor. You can get it in multiple different variants, different communication protocols, different heating configurations. It measures accurately up to 90 meters per second. Of course, I think vessels typically try to avoid these wind speeds, but it's good to know if you have that kind of a requirement. You never know. Works in heavy precipitation, very wide temperature range, and like I said, really powerful heating, so it works in all conditions. Compliant to various different regulations and certifications at different standards. So this is like the flagship product that we have for wind measurement only. Then going down to the WXT530, and this is not just a wind sensor, but this is actually an all-in-one weather station, and you can order it in different configurations. So you can, for example, have a rain detector on it, pressure, temperature, humidity, and also wind speed, and then you can get these in different kind of combinations. What's interesting here is that when you connect it to your systems, you get all of these measurements in the same communication line. So that's tempting for some customers. It is also, let's say, less expensive if you have a wind-only variant compared to the WMT700. And for some customers that are operating in this kind of like not so extreme conditions, this is a really good option where they don't have to have, for example, super freezing conditions or things like that. It's reliable, maintenance free. Sorry, go back one more time. So the rain detector, for example, if you need to measure precipitation, it has no moving parts. It uses this kind of a piezoelectric acoustic detection, so it's really good, and also low power consumption in some of the variants. So this is really good all-in-one weather station. And then we have the weather API. So we also have this forecast data service, and this has all the commonly used weather parameters. You can get a forecast for the current conditions, 15 minutes, hourly, and daily. And then we have these additional, let's say, AP or add-on models like the maps and the warnings, etc. So you can really get it also from Vaisala. So in that respect, we are really like an all-in-one weather house. And then going to these LiDARs, which is, I think, really interesting, because if you look at what the anemometers are doing, you're essentially measuring what is the wind at the installation location, the time of flight, how the wind affects the acoustic signal, etc. But what these LiDARs enable is measuring the future, like what is the wind, let's say 100 meters, 500 meters, even 700 meters in this example picture, from the point of measurement. So it's essentially doing this kind of a Doppler measurement like you have with the police with the radars that are trying to catch you for speeding, but a lot more complicated and more lasers and a lot of science behind it. But essentially, like, long story short, you can measure the wind before it hits you, and what this allows you to do is be ready for it. And this is really like ingenious. And I think there's lots of great opportunities, lots of optimizations that can be made when this is adopted, and when the whole, let's say, wind-assisted market catches wind and reaches its full potential. And we have another variant, of course, also in the LiDAR. So we had in the previous slide the forward-facing. We also have a like top-facing variant. So you can measure, for example, what is the wind profile 300 meters above your vessel. So if you have these kind of sail rotors or other, let's say, different structures that are really sensitive to the winds above deck, then this is really useful, because in some cases you just cannot have a really high mast. It's not practical or possible even. But if you're really interested in these wind speeds at high altitudes or like hundreds of meters above deck, this is the way that you can do it. So in summary, we have actually three different LiDAR variants. We have the forward-facing, the top-facing, and then we also have a scanning one, which you can create a three-dimensional scan of the wind field around you. They have been developed and validated with industry-specific IEC regulations, and they have these DNV, etc. certifications for maritime operation as well. So they are there, and they are really capable to enabling, let's say, great things in the future.
Thanks, Timo. We did also the survey together with IVSA during the springtime, and here is some of the results from the survey. We'll go these briefly through, and maybe, Gavin, if you want to comment at the same time, please feel free to do so. So we went through a little bit about what sort of wind and weather measurement needs there are among the wind-assisted system suppliers, and of course, the local wind measurement is considered to be very important from the optimal performance of the propulsion technology, so that you can optimize the system. You know when to turn it on, when you should turn it off, or if there is some emergency situations, also how to deal with those one. And of course, the wind measurements includes also the LiDAR possibility in the future. And these were seen to be helping to find the right route, and also to be utilized together with the system optimization for the safety, emergency shutdowns, and automatic system start and stop. The weather forecast, together with the local wind observations, is seen as the most important ones for the wind-assisted vessels. And then there was a couple of key challenges with existing wind sensors, and we are talking about the sensors which are existing already on the ships. And sometimes these are not providing really high quality data from the wind-assisted system perspective. Sometimes those are also placed in the suboptimal location at the vessel. And sometimes there might be even some superstructures masking the wind sensing, so that you are not able to get the accurate wind data from the ship. And if we are talking about really old vessels, or let's say which have been there sailing for years already, sometimes also the calibration and maintenance functions are not done for the wind sensors in the way they should be done. And if you have very rough conditions, of course, also the sensors are something which can be kind of worn out by the rough conditions. So you should change those time to time if that is needed. So these were the kind of the issues which were seen in the survey. And then the challenges and the future requirements from the system optimization perspective is that the masking effect was seen as the number one. So we should get somehow rid of that and install the sensors in the right locations on the ships. And of course, then the superstructures which might cause also the turbulence and the sudden wind direction shifts around the vessel is something which have been seen problematic for some of the systems, like I could imagine that some kind of kite-based solution might cause trouble if you are not seeing the gusts coming in. And then the optimal weather routing solutions are quite scarce at the moment. So I know that there is development ongoing on that front, but still for the wind-assisted systems, it's very rare availability at the moment. And then the parameters on ships considered important for the system optimization. Of course, the wind speed and direction is the number one, but also the temperature, humidity, precipitation, waves, currents, and some other parameters were seen as important as well.
Climate change and air quality are driving big changes in the shipping industry, and shipping operators are looking for ways to use less fossil fuel. Starting in 2023, all existing ships must meet new energy and operational efficiency standards in the journey of meeting the 50% IMO CO2 reduction targets by 2050. This is a major challenge, as inexpensive carbon-free energy sources are hard to find and take time to build, except for the one that has always existed: wind. Wind-assisted propulsion is one of the key technologies in decarbonizing the future of maritime shipping. With modern wind propulsion technology, ship owners can offset the use of fossil fuels with an energy source that is low-cost, clean, and mostly available. Wind-assisted systems can be retrofitted to ships in a matter of days. The goal of wind-assisted propulsion is to maximize thrust from the wind, and the ability to nowcast upcoming wind conditions can make a huge difference in optimizing propulsion power. With Vaisala's marine-proof wind sensors and LiDARs for remote wind measurements, you never miss a chance to maximize wind power. The sensor's exceptional forecasting accuracy, durability, and maintenance-free design, plus global customer support, make sure that the best available winds are always captured for system optimization. Accurate, local wind data can also be used for switching on systems or triggering emergency shutdowns in stormy conditions. Vaisala's wind sensing solutions are compatible with all wind-assisted propulsion technologies. With the right access to the right information, maritime leaders can harness incredible new insights and address pressing challenges driven by climate change. The weather affects maritime operations onshore and offshore more than any other factor. We'll help you master it. Learn more about the solutions helping to propel the future of cleaner shipping.
But that was, I would say, interesting input from the players and from the market to kind of see that where we are at the moment and where we should be heading in the future from the sensor development perspective. So that was very valuable for us.
Yeah, and I think it's only going to be growing this area. I think the optimization issue, especially as we're getting through to the new builds as well. Where we've got primary wind vessels coming in with very, very strong components. The optimization is going to be really important there as well. Timo, I really liked your comment on an all-in-one weather house. I like that. Ship, yeah. Maybe an all-in-one weather ship, but yeah, that's great. Really interesting presentation. I mean, it looks like a sort of multi-layered aspect here. You've got weather routing, you've got weather forecasting, you've got the sensors, you've got the LiDAR, giving those various different levels of understanding of what is coming into the ship. And it was really interesting to see the LiDAR material. I was just wondering, on one of the slides it was talking about 700 meters out with a mono-directional LiDAR. But then there was the one that does the scanning, and that was talking about between 3 and 10 kilometers out. I was just wondering what is the difference there? How is that different?
Well, I mean, of course, when we're talking about distances like 10 kilometers, then the Earth's curvature is starting to also play a part. So if you have a forward-facing LiDAR, then of course it's also a different type of, let's say, electronics inside, different type of power and different type of laser, etc. But so to say, the scanning LiDAR, it's intended not only to measure along, let's say, the surface, but also going into the air. So it's optimized for that, and for those reasons you can get different kind of specifications. Now I just want to note that the numbers that we had in the example, they are not necessarily the maximum ranges that you can get with those. So if you want the full specs, you need to go to the Vaisala.com website to see what they are.
Right. No, it's fascinating because this brings wind propulsion into a whole different realm, if you like. A lot of the shipping industry looks at the systems in a way as a sort of a passive system. Yeah, you're going to adapt it a little bit to the wind conditions, but this adds many layers to that with weather forecasting, the weather routing, and also this LiDAR approach. I was just wondering, Mikko, if you could help me out with this one around the integration of all these systems coming together into a package for an automated system wind propulsion. I mean, how complex is that integration process?
Well, Vaisala role typically is not going into that direction that we would do the, let's say, full-scale SCADA integration, but that is our customers who are dealing with that one. And typically the wind-assisted system providers are doing the integration. They are taking all the sensor inputs into the system, not just the wind, but also the others, and then putting that everything in place. When it comes to the wind and other parameters from the environmental perspective, we can of course provide different kind of parameters there as a further inputs. And I would imagine that some kind of a systems like these kites, for example, is something that needs also maybe pressure information could be interesting for that one, and humidity in some cases might be interesting. Wave information definitely is interesting for some of the cases. So we try to keep our role to provide these different kind of parameter data for the system providers.
Yeah, because I think that's a very important point with the with waves. When I'm talking to ship owners, we're talking about wind propulsion systems, but actually we should probably be talking about wind propulsions systems, because each one of them has a unique characteristic. As you rightly mentioned, kites at 300 meters are getting very different wind conditions. A bow-mounted system and a stern-mounted system could be having different interactions at the same time. And Timo, you were talking about that. You have that difference in weather conditions around the vessel, and the freeboard interaction with the systems as well. The superstructure, the side of the vessel. Again, as we've got relatively small systems at the moment, those are growing in size. So I'm assuming that you're going to have different interactions at the base of a rotor and at 35 meters, or maybe we go to 50 meters. I know some rigs are looking at 100 meters. So we're going to have different interactions there. Where do you see? Okay, so I want to kind of expand this a little bit more, but where do you see the sort of prime markets for wind technology, the shipment segments? Where are you seeing the growth? And obviously that's going to be important for Vaisala's sales into those markets as well.
Yeah, of course, we are talking about overall global markets in every way. But if thinking of the specific vessel types, I would say that the bulker and tanker shipping seems to be the most interesting ones at the moment. They seem to be having also the investment money available for this type of systems, and they feel the pressure coming from the market that you need to do something for the CO2 emissions. So all in all, but I would say that these routes which are going through the big Atlantic or Pacific oceans, those are definitely the ones where you could benefit the most from the wind-assisted systems. Right. And if you have then the specific vessel types like the bulkers, tankers, etc., so I think there the combination is right. Where we see the most of the development at the moment happening, it's in Europe. But when you think the kind of a scalability of the systems and the market, it would be very natural that it will happen in Asia, in China, in Korea, where the major shipyards are. And when you have the new builds done with the wind-assisted systems already, it would be very natural that the growth would be coming from the geographical perspective from the Asia.
And I completely agree with that sort of geographical shift that's likely to happen. I mean, you go where the routes are, you go where the businesses, you go where the ships are. And it's interesting, actually. You mentioned that Vaisala is in 100 different countries. So this is one of the big things that comes up when I talk to ship owners is, okay, so I've got this great wind propulsion technology, but how do I get it serviced? How do I get it maintained? Which yards are specializing in this? And that's a bit of a chicken and egg thing, but it would appear that you have the sort of service and maintenance ability worldwide. Would that be correct, Timo?
Yes, so we have various different service centers. I don't remember the exact number, but a handful, which are like physical locations around the world. And there where we don't have our own, let's say, physical presence, we have our representatives stationed out. So in almost each country where we operate, and we have either our own, let's say, salespersons, or then we have our representatives. And depending on the needs of the customers in that location, then we also have this like service capable maintenance partner located there. So depending on the product, depending on the case, they can do something in the country, or then they can, let's say, ship it to another service center somewhere else in another country to get that maintenance.
Gotcha. Yeah. No, I mean, and I think this is going to be it'll be a growing amount of service for the wind providers, but also a growing concern as more and more ships are outfitted with this. So you mentioned some of the different ways and technologies that are used to measure the wind. And you also mentioned wave, Mikko, as well. And of course, we get more wind, we get more wave. So there's always you're given with one, and you're taken away with the other. And I'm just wondering, other ways or technologies that are available to measure the wind on vessels currently, and are those really applicable to when you're using wind propulsion? Because you've got an anemometer on a vessel anyway, and you'll have some form of weather station. But are those really applicable to the scale of wind propulsion that we're talking about?
I would say that I don't see too many of different new technologies coming on. Traditional anemometers maybe will be replaced all with the ultrasonic wind sensors. That's for fact. And then we see this LiDAR coming into the picture. But in what way and what will be the major use case for the wind LiDARs in these ships? That is still a little bit about the question mark. It might be part of the design work of the ships. It might be kind of part of the digital twin when you want to create sort of results afterwards, after testings. You might do some performance testing of the ships with the wind LiDARs, which wasn't possible before, because now you can see the true wind couple of 100 meters in front. So in different use cases, the LiDAR is interesting. More importantly, I would say that when you have a number of let's say sails on the vessel, let's say 4 or 5, how do you guarantee that you have the best wind monitoring capabilities in each part of the vessel? Because you have a blocking effect more. So you need to somehow adjust that, and I would say that you probably need more wind sensors per vessel than just 1 or 2. That might be one possibility to cover the vessel better, and then added that with the remote wind information is something that would bring some new elements into this game.
So this is going to be definitely a part of that sort of design iteration of optimizing the systems, building on those, testing, monitoring these, because we're still, frankly, we're still at the very beginning of this market.
Absolutely,
yeah.
Nothing. I mean, there's quite a lot of innovations to be done in this market. I'm quite sure about that.
Yeah, and we focus on the sort of 60,000 to 100,000 large vessels, but there are millions of smaller vessels as well in commercial use, fishing vessels, small sail cargo, ferries, which are under that level. So I'm interested to see if that will be a market in the future for these technologies as well. Timo, I've got a question for you. You've got this variety of wind propulsion systems, as I mentioned. How compatible are those wind sensing technologies with each of these? For example, you've got Flettner rotors, which are active systems. You've got the kites, you've got suction wings, which are passive, internally active, but passive. So is there an issue around the receiving of the data and then applying it to each of those different wind technologies? Or as Mikko mentioned, that integration a little bit for the OEM to deal with. But I was just wondering about, what are the differences?
Well, I think Mikko said it pretty well, that there are no new measurement or sensing technologies apart what we already covered here that are needed, or at least coming, that we are aware of for this sector. So the current technology is pretty fit to already answer the different kinds of demands there are. So it's more of just finding out what they need to measure, how do they integrate it, how do they build their SCADA systems, where do they actually need to have, if you have a physical anemometer somewhere on deck, where do they have to have it so you optimize the shadowing effects, etc. How many do you need? If you have a kite system, then where is like geometrically, where is the interesting wind field that you want to measure if you're using a LiDAR? How early do you need to have an indication of let's say dangerous gust, so that you have time to coil it in or whatever you need to do. So it's all about doing that, let's say industry specific optimization, which is something that needs to be done on the OEM side. we're of course willing and able to help, but at the end of the day, it's part of their optimization.
So we've got the kit. Tell us where to point it.
Exactly.
And what you want us to measure.
The data format are still the same like before. NMAA is typically used there, so no difference is there. And I think it's more of the use cases. How do you utilize the data, and what is the purpose for the data? And most of these systems are somehow that you need to kind of erect the sails, or you need to wind up the kite to the sky, or something like that. So the timing comes important, and when you do that, there the wind data becomes more important.
Right. Now that makes a lot of sense. And so what is the future then? What is the future for wind sensing in wind propulsion? Your crystal ball time. You've got off the shelf systems. I'm sure you can do bespoke combinations of those systems. But what's the future?
I think you said it quite nicely already. I mean, you said, is it the combination of these systems? I could imagine that when we have the weather forecasting capabilities, we have the local observation capabilities, and then you have the near wind or remote wind with the wind lidars. Maybe some kind of a combination of these all levels is something that, and of course the route optimization itself is something that is making the most efficient wind-assisted vessel of the future.
And of course, I mean, Timo, I'm going to throw in another little question here. Climate change. We're going to see winds. We've got lots of historic wind data for wind routing. Do you imagine any kind of changes in, dramatic changes or big changes in sort of wind patterns or trade wind routes, these kind of aspects, or do you think that will be quite a gradual sort of shift or mix when it's averaged out?
Well, I'm not a climate scientist, so I can't say exactly like where the big changes are going to be, but I think we can all agree that the consensus is that there's going to be more extreme weather events due to climate change, and that means that also the ships are going to see them more and more. And then if we have, let's say, larger, more capable vessels, and we have, let's say, like societal cost pressure, then they might be taking more risks. We don't know. So whatever the case is, the situational awareness is something that needs to be like top notch in the future, so that we can, let's say, navigate this more demanding oceans in the future with regards to extreme weather events.
I think that's maybe the perfect answer, even though you're not a climate scientist. So, and you've got the solutions to help with that. Oh. So that's great. I'm going to do a quick sort of five minute quick quick fire Q&A, and it's really up to you. You can both answer the questions, or one of you can answer the question. Really depends on you. And please just give me a sort of one sentence answer, not a yes or no. A little bit more than that, but not too much. Okay. So, how did you get, Mikko? I'll start with you. How did you get into this field? So firstly, sensing, the sensing world, but also wind propulsion.
Well, I was actually trying to look for new sustainable growth area for our maritime business, and then I kind of saw this opportunity, let's say 3 years back maybe, and then trying to find out what is our way into that area, and here we are.
Timo, how about you? How did you get into this person?
Well, I studied in the university like many years ago. Okay, maybe not as many as for others, but and Vaisala is like one of the top employers like in this kind of like high tech in the Helsinki metropolitan area. So of course I had to apply to Vaisala, and I was really happy to get accepted. And then some years as a research scientist, there was some really interesting job openings, and I was like, hey, this sounds really cool, and I was happy enough to get it. And since then I've been working with different let's say measurement areas, and right now wind is one of the various areas that I have in my products. So it's super interesting.
And that leads me to another question. Mikko, are you hiring at the moment?
Yes, Vaisala is hiring at the moment, and we have quite a lot of many positions open globally.
Right. Okay. But Timo's going to keep his job.
Definitely.
Hopefully.
That's only a joke. That's a very bad taste joke. I apologize. What is the most difficult question you get asked about wind sensing? That's either of you.
Well, maybe some of the shipping companies are asking that what is the best system at the market at the moment. Very difficult to say because it's quite a new market and innovations are happening all the time. So that's very difficult for me, at least.
So as long as it has a Vaisala badge on it, it's the best.
Yeah, we are compatible with all of those.
Okay, Timo, what's the most difficult question you get asked, maybe around your job or around this sensing in wind?
Well, I don't know if it's like a difficult job, but like coming from the background as being a scientist working in the labs, I think it never ceases to amaze me how complicated the real world is. And how many things there are to learn from the real world that you need to, let's say, consider when you're designing new sensors, for example, right. or when you're working with something that you have.
And then you throw the human element in there. Yeah, everything goes out the window.
Yeah, so you can never assume that you know everything. I think that's like the key takeaway. There's always something that you didn't consider. There's someone doing something very that might seem strange to you when you hear of it, but then when you go meet that customer, there's a perfectly good reason why they're doing it, and you just have to like remain curious all the time.
No, I think that's very true, and I think what you were talking about, making the systems robust, as weatherproof as possible. Thinking about corrosion. I mean, we're working in one of the most difficult environments of anything for it, with high vibration, corrosive air and water. Yeah, and then the human element as well. So one last question. If you could change one thing, if you could change one thing around your movement into wind propulsion. So Mikko, you were talking about 3 years ago, you were looking at this market. What you know now, how would that inform yourself if you could go back in time 3 years and talk and have a chat with yourself and say, Mikko, don't do that, do this? What would it be?
I think I wouldn't do too much differently by myself. What I hope from the market is really to have a sort of a regulation in place, which would be helping this market to proceed, because I see it's a clear opportunity. It's a no-brainer for everybody. I just hope that these conceptual proofs would come earlier and sooner, and the regulation would come into place, and there would be a price for CO2 ton.
Yep. So a little bit more on my plate, you're saying. Get the regular push for. Okay, all right, fair enough. Message received. Timo, anything that you would tell your 3-year younger self?
Well, maybe 3 years ago I was working in a completely different field in Vaisala, so maybe I would have told myself that, hey, this is a pretty interesting segment. Maybe you should consider this as well.
Yeah, absolutely. Well, it's an unusual challenge. You guys are coming in pretty much right at the beginning of something, but something that's been done before, and in a sense with the wind turbine industry, there's some analogies there. We've done wind turbines for years, just not making electricity from them, and now we've got a whole new raft of ships out there using an age-old energy source again. So yeah, kind of fascinating area. Gentlemen, I'd just like to say thank you very much. But before we go, I'm going to give you one of you. You can choose. I think it's going to be Mikko to do just a quick roundup statement. What's the takeaway the audience should take?
So I think whatever the kind of systems you are working with for the wind assisted ships is, And if you have a needs for the, let's say, wind sensing or remote wind or weather forecasting or whatsoever, just contact us and we are happy to support you. And in terms of the let's say, innovations and new development, we are also interested about that side. So we are always interested and curious that what might be happening in the future with these sensing technologies. So very interested to discuss further on.
Excellent. Yeah, I think that curious nature is one that's going to keep you in good stead as we move forward. Yeah. So Mikko, Timo, thank you very much for joining us today on Listening to the Wind. And to our audience, thank you for joining us too. And of course, if you have any follow-up questions or you want to talk to Vaisala about their product line and about future developments, then please contact them directly. And if you've got questions about how this could maybe fit into what IWSA is doing in the future, then I'm always available to talk and answer those questions. So once again, I'd like to say thank you to the audience as well for joining us on Listening to the Wind. And I'm looking forward to seeing the developments in this market going forward over the next couple of years. Thank you, Timo and Mikko. Thank you very much.
Thanks.